Greetings, I am S. Chandra from the Department of Mathematics. Our discussion topic is equations of the first order and of the first degree. That is, basic is differential equations. What do you mean by first differential equation? Differential equation is an equation in which differential coefficients occur. What do you mean by differential coefficient? Suppose I will say one example of the differential equation, dy by dx equal to sin x. So this is dy by dx is differential coefficient. Another one example is d square y by dx square plus 5 dy by dx plus y equal to 0. So this equation contains two differential coefficient, dy by dx and d square y by dx square. Now, differential equation are of generally two types. One is ordinary differential equation, another one is partial differential equation. There are two kinds of this equation. First, we will discuss about ordinary differential equation. Generally, it is referred as ODE. Ordinary first letter O, differential first letter D, equation first letter capital E. So simply it is called as ODE. Okay. So what do you mean by ODE? ODE is that is D means differential equation in which a single independent variable enters. Single independent variable enters. So there are variable means two kinds of variable. One is dependent variable, another one is independent variable. So what is, now first I give the example is dy by dx equal to sin x. So what is y? It depend on x. So y is dependent variable and x is independent variable. In this equation, it is only one independent variable, that is x only. So single independent variable, that means only one independent variable enters. So this is the example. So I will say dy by dx equal to 2 sin x. This y is dependent variable and x is independent variable. So only one independent variable is here. Therefore it is a ordinary differential equation. Okay. Next, partial differential equation. So simply called as PDE. So partial first letter capital P, differential capital D, equation first letter capital E. So it is called as PDE. Okay. So partial differential equation is a differential equation in which two or more independent variables enter, but in ordinary differential equation only one independent variable enter, but in partial differential equation two or more independent variables enter. So the example is x dou z by dou x plus y dou z by dou y equal to z. Here z is a function of x and y. Z is a function of x and y. That means z is dependent variable here, but x and y are two independent variables. So in this equation, two independent variables enter in this equation. So dou z, we can using the symbol. This symbol is referred to as partial differential. So x dou z by dou x plus y dou z by dou y equal to z. It is an example of partial differential equation. Here dependent variable is z, two independent variables x and y. Next definition, order and degree of a differential equation. First we say that what is the order of a differential equation? Order of a differential equation is the order of the highest derivative occurring in the differential equation. Order means highest derivative. That order is called order of a differential equation. The degree of a differential equation, the same thing, degree of the highest derivative. But here the differential coefficients, that means dy by dx, d square by dx square, it is free from radicals and fractions. After that we can conclude how do you find the degree. So you will say that one example here, 1 plus dy by dx whole square power 3 by 2 equal to a d square y by dx square. Okay. So what are the two differential coefficients here? Dy by dx and d square y by dx square. Dy by dx and d square by dx square. Okay. What is the highest derivative? This is the highest derivative. So its order is 2. So d square by dx square is the second order derivative. So it is, I will take as order 2. But now we can to find out degree. So first, free from radicals and fractions. What is the radical and fraction is here? 3 by 2 is the fraction and it's the power also. So I can remove 3 by 2. We can use 3. So I will take on both sides square root. 1 by 2 will be cancelled. Here is 2 power. So this equation which is free from radicals and fraction. So we will now find out degree. What is the order? 2. This is power is 2. So it is degree is 2. So this equation has order is 2 and degree is also 2. Okay. Next, solutions of a differential equation. Generally, solution of a differential equation is a function which satisfies the given differential equation. Solution of a differential equation is just a function. It's also a constant also, but it is generally called as function which satisfies given differential equation. There are two kinds of solution in general. One is general solution and another one is particular solution. What do you mean by general solution? The general solution is the solution which contains as many arbitrary constants. How do you find out how many constants is there? What is the equation containing order of the differential equation? Here, order of the differential equation is arbitrary number of arbitrary constants in the general solution. And then particular solution is a solution free from arbitrary constants. In particular solution, no constant is there. I will say that in an example. The function, what is the differential equation? D square by dx square plus dy by dx minus 6y equal to 0. This is the second order differential equation. What order? Second order. Okay. So how many arbitrary constants is inside there in the general solution? 2 arbitrary constants. I will say what is the general solution for that? Y equal to C1 is one of the arbitrary constant. C1 e power minus 3x plus C2 e power 2x. C1 and C2 are arbitrary constant, the general solution. But I will here mention only particular solution. So its general solution is y equal to C1 e power minus 3x plus C2 e power 2x. There are 2 arbitrary constants. How will we say? This is the second order derivative. So second order derivative contains 2 arbitrary constants. In a particular solution, this is a particular solution because this does not contain any arbitrary constant. This does not contain any arbitrary constant. Okay. So y equal to e power minus 3x. How do you say that this is a solution for that? How? I will say y. We can find out dy by dx and also find out d square by dx square. So y equal to e power minus 3x. What is the dy by dx? We can differentiate minus 3 e power minus 3x. I can find out again differentiate d square by dx square. After simplification, we get 9 e power minus 3x. So I can substitute y dy by dx, d square by dx, all values in this equation in left hand side. We get answer will be 0. So substitute values of these values in given differential equation, we get left hand side. Put all those values in left hand side. This value after simplification we get 0, that is right hand side. Thank you. Now come to main point. Equations of the first order and first degree. How do you solve this? So I will take first one type, variable separable. This is one of the method to solve first order and first degree differential equation. So what do you mean by variable separable? Variable separable method is the one of the method to solve the differential equation in which the variables can be separated completely. How? Suppose there are only two variables, one is independent variable and another one is dependent variable. I will take as one variable x, another variable y. I will separate it. How do you separate? Y and dy in one side, x and dx in another side. That means terms containing y should remain with dy and terms containing x should remain with dx. So I will take one example. Solve dy by dx plus bracket 1 minus y square by 1 minus x square power 1 by 2. I can use it to solve this differential equation by variable separable method. So this is equation. I will come to this side. So dy by dx equal to minus square root of 1 minus y square by 1 minus x square. So we can separate this part containing dy and terms of y. This part containing dx and in terms of x. So this is we can clearly variables are separated in the equation. So next this is minus, we come to this plus. So this equation we can be integrate to solve it. So integral formula is integral dy by square root of 1 minus y square is sine inverse of y. Integral dx by square root of 1 minus x square is sine inverse of x. So after the integration we get c is an arbitrary constant. Therefore this is the solving the answer. What is the solution of the differential equation? Sine inverse y plus sine inverse x equal to c. So first order first degree, I will take another type to solve that equation. The type is called homogeneous differential equation. So we can use it to solve the first order first degree equation by homogeneous differential equation. First we know that what is homogeneous function. A function f of x comma y is said to be homogeneous function of degree n. So I can write it as if we can replacing x2 lambda x, y2 lambda y. That is f of lambda x comma lambda y equal to lambda power n. That n is called degree n f of x comma y. But that lambda is a constant, but is a non-zero constant. So a function f of x comma y is said to be homogeneous function of degree n if f of lambda x comma lambda y equal to lambda power n f of x comma y. That n represents degree n. Here lambda is a constant, but it is a non-zero constant. So this is the example of homogeneous function f of x comma y equal to y square plus 2xy. This is the homogeneous function of degree 2. So what I will get? F of lambda x lambda y equal to lambda square of f of x comma y. Okay, so we can replacing x2 lambda x, y2 lambda y. Here also y is lambda y whole square, x is lambda x, y is lambda y. So f of lambda x comma lambda y equal to, we can substitute it and separating the lambda square from outside, y square plus 2xy is again f of x comma y. Therefore f of lambda x comma lambda y equal to lambda square of f of x comma y. So we can, so it is degree 2. This is a function, homogeneous function of degree 2. Now we will discuss about homogeneous differential equation. So what is homogeneous differential equation? So differential equation means compulsory differential coefficient occur. But we will now discuss about first order and first degree. So we will take as this form is dy by dx equal to f of x comma y. How do you say that this is homogeneous differential equation? That function f of x comma y is a homogeneous function of degree 0. That is called as homogeneous differential equation. So I will take another example. For example, to solve homogeneous differential equation is solve y square plus x square dy by dx equal to xy dy by dx. Okay. So we will make it as general form y square plus x square dy by dx equal to xy dy by dx. First, how do you say dy by dx equal to f of x comma y? So I will come to this after simplification. We get dy by dx equal to y square by xy minus x square. This is the format for how to check the homogeneous. So I will take this as f of x comma y. So f of x comma y equal to y square by xy minus x square. I can find out it is a homogeneous function of degree 0. Yeah, you can replacing x2 lambda x, y2 lambda y. After simplification, this is called y square by xy minus y square. That is lambda power 0. Lambda power 0 means Degree 0. Therefore, it is a homogeneous function of degree 0. So, this differential equation is called as homogeneous differential equation. So, lambda power 0. Therefore, one is a homogeneous differential equation. How to solve for that homogeneous differential equation? We can substituting. What is the substitution? Dependent variable equal to v times of independent variable. That is called as y equal to vx. We can differentiate dy by dx is v plus x dv by dx. We can substitute y equal to vx and dy by dx equal to v plus x dv by dx in the given equation. We get that answer. So we can just solving this v square x square vx square minus taking outside common is x square will be cancelled. I will get it v plus x dv by dx equal to v square by v minus 1. So x dv by dx plus v, this comes at minus v. So after simplification x dv by dx equal to v by v minus 1. So after substituting, this equation easily solvable by variable separable. Because of that, v is one of the variable, x is another variable. I will separate v and dv in one side, x and dx in another side. So we can now integrating this. So 1 is v, 1 by v log v, dx by x log x integration plus c. So v equal to log of x plus log x plus log c. We know that the formula log a plus log b equal to log ab. So we can using this concept log v x c log. So first I will substituting in homogeneous v y equal to vx, that is v equal to y by x. So after replacing v equal to y by x, log of this also y by x, x will be cancelled, y by x equal to log yc. So this is log. I will take both sides on exponential. Therefore, e power y by x equal to e power log will be cancelled yc. So therefore, y equal to 1 by c e power y by x. The final answer is y equal to c e power y by x. So another type. This is to resolve first order and first degree. Linear differential equation. What is the form for linear differential equation? dy by dx plus py equal to q. This is the linear differential equation. That p and q is only constant or function of x only. X means independent variable. So this is called as linear differential equation. That is dy by dx plus py equal to q. P and q are constant or functions of x only. So now for an example to solve this, dy by dx plus y cos x equal to 1 by 2 sin 2x. You can comparing this equation dy by dx plus py equal to q. Therefore dy by dx, p value is cos x, q value is 1 by 2 sin 2x. Clearly p is a function of x, q is a function of x also. So method is, what is the solution format? Y into e power integral p dx equal to integral q into e power integral p dx dx plus c. So e power integral p dx is called as integrating factor. So we can find the first integrating factor and then substituting this we get the solution. So now to solve. So integral p dx. So integral cos x dx. Integral cos x is sin x. Integrating factor is e power integral p dx, e power sin x. Now we can find out integral q into e power integral p dx dx. So integral q is 1 by 2 sin px, e power integral p dx, e power sin x dx. So sin 2x formula we know that 2 sin x comes x. 2 will be cancelled. We can using substitution method to solve this integral part. So I will take a substitution sin x equal to t. Therefore cos x dx equal to dt. So sin x equal to t, cos x dx equal to dt. So e power t dt. This integral we can solve by the Bernoulli's formula or integration by parts. That is formula, what is the integral u dv equal to uv minus integral v du. So we can using this, that is u dv, integral u dv. What is the formula? uv minus u dash v1. u t, v is e power t minus u dash, that is differentiation. Differentiation of t is 1 and then v1, that is integration of e power t is e power t. And again differentiation of 1 is 0. So I will stop here. That is Bernoulli's formula plus c. So common is e power t minus 1 plus c. We can replace in the substitution sin x equal to t. Therefore e power sin x minus 1 plus c. That is, this is the idea. So we can using integrating factor on this value in the solution is y into e power sin x equal to e power sin x minus 1 plus c. So I will give one example, but you can try yourself. So the equation is dy dx plus y tan x equal to cos cube x. So I will give some hint what is the integration of tan x log secant x. This is integrating factor, and then we can find out this answer after simplification, this answer this. So you can try yourself. Now this is Bernoulli's equation, another type to solve first order and first degree. Bernoulli's equation. This is the format is also same as linear differential equation, but some changes here. dy dx plus py equal to q is the linear differential equation, but here Bernoulli's equation q into some y value y power n. That y power n will be y cube, y power minus 3, anybody is there. This is Bernoulli's equation. The same from linear differential equation, Bernoulli's equation also, if p and q are constants or function of x only. So question, solve. I will take one example, dy by dx minus y tan x equal to sin x cos square x by y square. I will separate it like Bernoulli's form, that is p is function of x minus tan x, q is sin x cos square x, this is y power minus 2. How do you solve? First you can remove y power minus 2 from here. So I will multiply this equation by y square. So y square means y power minus 2 remove. So after that I will get it y square divided x plus minus tan x y cube equal to sin x cos square x, y power minus 2 is not here. So what is the substitution is here? Compulsorily coefficient of p, that is this is p. What is the coefficient of p? Y cube. So I will take as z equal to y cube. So z equal to differentiate dz by dx, and then we can substitute y square dy by dx. From this concept I will take as y square dy by dx equal to 1 by 3 dz by dx. So substituting here y square dy by dx is 1 by 3 dz by dx, y cube as z. This equation is to be changing into like as linear differential equation. So from Bernoulli's equation, how do you convert it to a linear differential equation? This linear differential equation simply, this is function of x, this is also function of x. What is the complete solution of this equation? Z. We can using the here z. Already I will take as problem is y. So z e power integral p dx equal to integral q integral e power integral p dx dx plus c. So this is dz by dx plus dz equal to q. What is the value p? Minus 3 tan x. What is the q? 3 sin x cos square x. So integral p dx after simplification p dx will be minus 3 tan x minus integral tan x minus 3 integral tan x is log secant x. So convert last answer is log of cos cube x. Okay. So integral p dx equal to log of cos cube x, e power integral p dx is e power log of cos cube x, e log, so that is cos cube x, and because exponential and log are opposite concepts. So integral q e power integral p dx dx equal to integral q is also known as 3 sin x cos square x, e power integral p dx is cos cube x dx, sin x cos power 5 dx. We can using to solve this integral by substitution method. So I will take as cos x equal to t. So cos t power 5 minus dt. So t power 5 t power 6 by 6. T is also substitution is cos x, cos power 6x by 6. So solution is z into e power integral p dx equal to integral q e power integral p dx dx plus c. Thank you.